All right, we're live. Welcome DS15. This was the first lecture of your time here at Lambda School, here in Unit 1. Today, we're going to talk about two major topics. These are broken down into some smaller objectives. We're going to talk about how to submit your work while you're here at Lambda School. We're going to use a tool called GitHub, both for kind of just storing all of our files, storing all the work that we do, and we're going to have you use GitHub to submit your assignments throughout your time here. You're going to find that working with GitHub at the beginning is a little bit confusing, or a lot of bit confusing. It's going to be kind of annoying as you get started here, but we're going to use it so often. We're going to use it day in and day out to the point where it will become kind of second nature to you. So don't be worried if you find it confusing today. I think that's totally normal. And then what we're also going to do is we're going to start building upon some of the things we did in the pre-course work. We're going to review a few things. You know, how do we load a data set into a notebook using the Python library pandas? And then how do we do some basic data exploration of that data set using the pandas library, right? So we've done a little bit with pandas in the pre-course work. It shouldn't be totally new. However, there's a good chance that most of you, if not a few of you, are pretty new to Python. And so hang on, just do the best you can, and we'll be here for helping you out if you find that the pace is maybe a little fast or something. Bring that up with your team leads, and we can try and address that. All right, so that's our focus today. Help you know how to submit assignments, how that's going to work while you're here at Lambda School, and do some basic data exploration with pandas. All right. One thing that I should say here is I'm going to share a link with you to an application called Slido, S-L-I-D-O, all right? So there's that link there. Go ahead and click on that link for me. And what you'll see is an application where you can ask questions. Slido is the most formal way you could ask questions during a lecture, right? So you can ask questions. Everybody jump in Slido and ask me a question, all right? Slido is gonna fill up with all kinds of stuff, all right? I'll even share my screen so you can see them as they're coming in. Are you related to Austin? Yes, I am his younger brother. How are you? I'm well. All right, so great. Now what I also want you to do is you can see that you can upvote one another's questions, right? So if there's a question that you also share that you would like answered, go ahead and upvote it. Try upvoting a couple of questions here. We'll see what rises to the top. Okay, you see the ones that have the most upvotes here going to the top. And if I go to present mode, we'll get a fancy little way of viewing these. All right. So Slido is one of the main ways that you will ask questions during lecture and get those questions answered. There'll also be discussion in just the DS15 chat. However, I reserve the right to ignore anything in the DS15 chat. All right, you guys might be, saying some silly things in there sometimes. I will watch and respond to both. However, if you want to make sure a question gets answered, Slido is the place to ask it. So where you can get those awesome Lambda jackets, there's a Lambda School swag store. I don't remember what it's called. One of the team leads, Lambda School Shop, something like that. Yeah, lambdaschoolshop.com. I think you can get some swag there. Right, and this is kind of how we'll go about answering questions with Slido. Okay, so I'm mostly going to ignore all these questions right now because there's there's some good ones here. All right, after I've answered a question, I will archive it, and then you can also view the archived questions after I've answered it. But that's just so that I don't answer the same question twice, right? Can you explain the 20-minute rule to those that need clarification? That is a great thing to talk about right now. So the 20-minute rule is a policy we follow here at Lambda. What that means is in the afternoon, as you're going about working on your assignments, doing things, if you get stuck on something, as you absolutely will, it might feel like you're just constantly getting stuck on things. That's part of the learning process here with code is, learning this syntax, learning this new way of doing things. All right, so you're going to get stuck quite a lot. The 20-minute rule means you spend at least 20 minutes doing everything you can think of to solve your own problem before you reach out and ask for help. All right, so that means you're Googling your question, you're trying to read documentation, you're reading Stack Overflow, right, before, spend 20 solid minutes doing everything you can think of to solve your own problem, and then reach out to your team leads for help. And as necessary, if team leads can't address your question immediately, then they'll escalate things to me and I'll answer it. And if I can't answer it, I'll escalate things to my boss, Aaron Gallant, who's the program manager of the data science program. And if Aaron can't answer it, then no one probably can. And I'll have to say, I'm sorry if you can't answer your question. No, I'm just kidding. Somebody will probably be able to get some help. But that's the 20-minute rule. Spend at least 20 minutes digging in, but also do not spend more than 20 minutes either. All right. I don't want you to spend 2 hours in the afternoon because there was some typo where you accidentally typed a comma instead of a period, and you're actually doing things right the whole time, right? I want you to be making good progress and to be unblocked on these learning activities. So also do not spend more than 20 minutes being stuck on something before you reach out for help. That's the 20-minute rule. All right. Now I'm going to defer a lot of these other questions here to a little bit later. I see this one got downvoted. All right. I'll answer some more of these asynchronously in the chat after lecture. All right. But I do want to get into lecture because we do have a lot to cover. So what I'm going to do is I'm going to archive these for now. Just everything that's here, just because that was just kind of an exercise in asking questions, and I'll come back to answer them. All right. So you'll notice that when you ask questions in Slido, your questions show up as anonymous. You can also add your name, and I encourage you to add your name whenever you're comfortable. But when we're starting off at the beginning of the course, I don't want you to be afraid to ask questions. I don't want you to be afraid that you'll have a question that sounds dumb or that other people, maybe don't have, right? So keep an eye on Slido throughout the day as you see questions that get asked. Upvote them to let me know that you share those questions. And I will try and take regular pauses in the lecture to address Slido questions as they come up. All right. So that's the first thing. We'll be using this tool somewhat heavily during lecture times. And then the second thing is, I want to go ahead and get started here and show you how to submit assignments here at Lambda School. So what I need you to do is I need you to go to github.com and I need you to log in with your GitHub account. All right. So I'm hitting you with a bunch of links there. All right. GitHub.com is the latest one. Come here, make sure that you are logged in. And I'm going to do something here. I'm going to send out a poll in our DS15 channel. I'll use this every once in a while to kind of just take the temperature in the room, see how you're doing, see if you're following along, see if you're caught up with me. Because I do want you to follow along with what I'm about to do, all right? But however, when I put polls in our DS15 channel, I will always or almost always make them anonymous. All right. If I do not make them anonymous, I will tell you. So poll here is I'm logged into GitHub, yes or no. Let me know when you're here with me, when you're ready to follow along. All right. Now, some of you may not have a GitHub account yet. If you don't, go and make one quickly. All right. Go sign up for one. You'll pick a username. And this will be a really major tool that we'll use throughout the entirety of the course. And you're going to need it to complete your assignment today. So go and make one quickly if you haven't. All right. But I see by and large, looks like I've only got about half of you have responded to the poll so far. All right. Keep responding there. All right. And then what I want you to do once you're logged into GitHub is I want you to come and look at the Lambda School account. So github.com/Lambda School. All right. Now, this is the Lambda School organization on GitHub, and this holds all of our content, all of our curriculum. Well, I would say 80% of our curriculum. There's a couple other places where it gets held as well, but largely this is where all of the files that we need to distribute to you for completing your assignments, distributing data sets to you, all those things will happen here through the Lambda School GitHub organization. So you'll notice here, we have all these different things that are linked to here. These are all different assignments, pieces of content used throughout our different courses here at Lambda School. So I think these things here in JavaScript, those are for some of the web courses. You can see this one that says Jupyter Notebook. That's more likely a data science topic, right? And you'll see here, DS Unit 1, Sprint 1, Data Wrangling and Storytelling. That's actually the file that we're going to use today. All right, so I'm going to specifically show you how you can find data science related repositories here on the Lambda School GitHub. So I'm going to use this word repository a lot. What does repository mean? It just means a folder of files that is stored here on GitHub, right? So each week here at Lambda School, we call that a sprint, all right? 1 week here in the full-time class is a sprint, all right? So that's just some more additional Lambda terminology for you. So for each week, we have one repository or one folder of files that you'll use for completing the content and assignments for that entire week, all right? So this process that I'm about to demonstrate will typically be something that you will do on the Monday of each week to get your assignment files set up and be ready to go and ready to do your work throughout that week, all right? So you'll come here to the Lambda School GitHub page, and you'll notice that all of our data science stuff is prefixed with DS in front of it. So we are here in DS Unit 1, all right? And we are in Sprint 1, all right? DS Unit 1, Sprint 1. And you'll notice there's a couple of different DS Unit 1 Sprint 1s. There's this one dealing with data wrangling, storytelling. Notice this dealing with data, it has been archived. So that's an old version that we don't use anymore, all right? The repository that we're gonna use for the whole first week is this data wrangling and storytelling repository. So go ahead and give that a click. I'll also share that link here in Slack, and if you want to navigate straight to it. All right, but everyone should be logged into their GitHub account and be on this same page that I'm on right now if you're following along. All right, now you'll notice that there are 4 different folders or kind of subfolders within this larger repository, within this larger folder of files, right? Modules 1, 2, 3, and 4. So each individual day of content at Lambda School, we call that a module, right? So today, Monday, we're gonna work on module 1. Tomorrow, Tuesday, we're gonna work on module 2. Wednesday, module 3. Thursday, module 4. And you'll notice there's no module 5 for Friday because we're gonna do things, we're gonna do a lot of different things on Friday. Fridays are kind of a bit different than our regular instruction days. So there's typically 4 main days of instruction and practice. And then Fridays are kind of dedicated to, testing your knowledge, making sure that, you've mastered the things from earlier in the week and assessing you to make sure that you've learned everything that you need to of the content within that sprint. All right. And we'll talk more about what we do on Fridays a little bit later. All right. But you'll see that in each of these folders, there are 2 files. We have LSDS111. The 111 here stands for Unit 1, Sprint 1, Module 1, right? So it's just saying where in the curriculum you're at. And then the title of that day's topic. So today's topic is exploratory data analysis. This first file here is a notebook where we're going to type all of our Python code, right? So you can see there's a lot of instructions here. This is actually a lot of text explaining the process I'm about to show you, just so you have it as a reference. And then down here below, we're gonna write some Python code here and practice doing some things a little bit later on during the lecture. So this is the file we'll use for demonstrating things during lecture. And then the other file is what you'll do on your assignment. So there typically be 2 files like this. One file we'll use during lecture, and the other file you will use to practice things on your assignment in the afternoon. All right, so that's kind of how our curriculum is broken down by unit, by sprint, by each week of content, right? And then by modules, which is each specific day of content. We've stored all of our curriculum files that you'll need here on GitHub, so they're all in one place, one good place to find them. All right. The question here is, we have all these files here, and I want each of you to have your own copy of them on your GitHub profiles, right? So if I come and look at my GitHub profile, okay, the green boxes are days I've made changes to files in my account, but if I click on repositories here, right, it will show you all of the different repositories that I have. Some of these are Lambda School related. Other ones are kind of my personal projects that I work on the side as well, right? But I want to take this Lambda School folder of files, and I want each of you to have your own copy of it on your individual GitHub accounts, right? So each of you is going to make a copy of these files, and that's where you're going to do your work throughout the week. So this is kind of the master version. This is kind of the template. All these files are blank here at the beginning of the week. You're going to make a copy here, and then you're going to work from the copy. All right. Now, in GitHub terminology, lots of new terms I'm throwing at you here today. When we say make a copy of this folder of files, we call that forking. Make a fork of this repository. All right. So what I want you to do, you're on this page with me, you're logged into GitHub. I want you to come and click this fork button right here. Now, you may not see the same window that I'm seeing. You might just automatically fork. This is because I have different accounts. So I'll click the account that I want this to be forked to. You probably only have one account, so it'll probably do this automatically. You'll see this little icon of a book getting copied, getting scanned with a fork stuck in it. All right. And then you'll land you back on a page very similar to what you were just on. All right. Now, this number here on the right-hand side, that tells me how many people have forked this repository. So I want to see that. I want to see that number jump up quite a lot here. I want you guys to fork this repository. If you don't do this right now, you're just going to have to do it before you can work on your assignment anyway. So you're going to need to do this very, very soon, even if you're not following along with me. All right. Now, I want you to notice there's a few things that have changed on the page since I forked the repository. Notice before it said Lambda School right here. It told me that we were in the Lambda School account looking at this folder of files, this repository, right? But now it says I'm in Ryan Lee Allred, which is my GitHub account. And you'll notice the little fork icon has showed up on the left-hand side here. That wasn't there before. This tells me that this repository I'm looking at right now is not the original, but it is a copy of the original, and it'll actually tell me where I can go and find the original. It says it's been forked from the Lambda School version. All right, so this is how we'll distribute a lot of course content to you. We'll link you to a repository, and then you'll make a copy of it to your GitHub account, and then these are the files you'll work with throughout the week. All right. GitHub is also the way that you will submit your assignments, right? So after you've made a change to, say, the assignment file for today, we want you to save those changes back to your GitHub account, and then the team leads will be able to access the files here on GitHub to see the work that you've done, give you feedback, and just make sure everything's going good with you during the course. All right. So the next thing I want to demonstrate here is how to open one of these files that's within a repository in Google Collaboratory, in the tool that we're going to use for actually writing code and making modifications to these files. All right. But before I go ahead and do that, are there any questions about up to this point about what I've shown, about what I've demonstrated? I'll look both at Slido and at Slack. Okay. So, and while you're maybe thinking of questions, I'm just going to talk a little bit more. The reason why we're using GitHub for this process is not because this is the easiest way to submit assignments. All right. We're using GitHub for this process because the same process that you will be using for submitting your assignments throughout your time at Lambda School will mimic very closely a process you'll use in the workplace for collaborating on projects with teams of individuals, right? So say that this Lambda School repository wasn't a repository of curriculum here at Lambda School. Say this was a website. And you were trying to build in some data science capabilities to that website. Maybe you're working with some web developers, some designers, right? But you're all sharing one big folder of files, and that folder of files represents that website, right? And you want to build some things into it, right? Well, what you would commonly do before you did your work as a data scientist is you wouldn't want to make modifications to the master version of the website. Well, you're going to fork that and you're going to make a copy of it. And you're going to do all your work on your copy until you make sure that you've got it all working the way that you expect on your copied version. And then once you've got that working, then you'll submit what's called a pull request. All right. A pull request means, hey, I've made these changes to this copy, and I think those changes should be incorporated into the main master version, the live version that people are actually interacting with in the wild, right? And so this submitting a pull request is a function you can use for other members on the team will see your pull request, and you'll kind of get together as a group and go through the changes that you've made, make sure you're not going to mess anything up, or review each other's code. Maybe you'll request some improvements beyond the changes you've made, right? But if you review the pull request and everything looks good to go, then you'll do what's called merge the repositories. You'll merge your forked version with the main version, and that's how you'll update a website with changes. But you'll notice this process allows lots and lots of people to work on one single code base, one single folder of files at the same time, right? You could have 10 people working on the same files. They all make their own individual copies and then work on those changes. You could have 100 people working on the same folder of files, and they all make their own copies to their own GitHub accounts. And then, as they're ready to have those changes be merged back into the original, they'll all open up a pull request. So we'll talk about pull requests a little bit later. So the reason why we are using GitHub here for this assignment workflow is not because it's the easiest thing in the world. It's because it is an industry standard tool that you're going to use again and again throughout your career. So we're starting with it at the very beginning because we want this to be second nature to you. We want you to be very comfortable with GitHub, but it's going to be challenging in the beginning. I'll just say that here and now. All right. So hopefully, let's see, this toolbar is in a really weird spot. Let me try that again. Sorry, Zoom toolbar ended up in the middle of my screen instead of at the top of my screen. I don't know if I know how to move it. All right, that'll work. You probably can't even see the toolbar that I'm talking about. So, okay, here's what we're gonna do next. All right, so you've hopefully forked the repository. You've made your copy of it. All right, now I'm going to show you how to open one of these files in Google Collaboratory. All right, so I need you to yet again navigate to another link with me, maybe in a new tab. I want you to go to collab.research.google.com/GitHub. All right, and I'll share that link also with you in Slack. And as you navigate to this page or click on this link, you will first be asked to log in with your Google account. All right, and then once you've logged in, you will probably not see the same thing that I'm seeing right now. All right, once you have logged in with your Google account, you will probably be seeing a prompt to give Google Collaboratory access to your GitHub. All right. You're probably going to see a place where you can log in here with your GitHub account. What this is going to do is it's going to allow Google Colab to automatically make changes to these files, right? So once we do our work in Google Colab, we type our code, then we can save our changes back and it will automatically modify the versions of the files that are here on GitHub. And then the team leads can come on GitHub and see the work that you've done. All right, that's basically what's going to happen here. But you do need to go and authorize Google Collaboratory to access and make changes to your GitHub account. And then once you have done that, you'll see a screen very similar to what I'm seeing. But you'll need to type in your GitHub username here in the search bar. And you'll also need to check the include private repos button. All right, so this is kind of a 3-step process here, or maybe a 4-step process. One is go to this URL, the collab.research.google.com/GitHub. 2 is authorize Google Colab to I don't know, access your GitHub account. 3 is type in your GitHub username in the search bar. 4, check the include private repos box. All right, this is something, that 4-step process that I just wrote there, you only need to do that one time. Here at the beginning, it's kind of we're just setting up the connection between those two accounts. Aaron says, it's not allowing me to access. Does that mean it's not allowing you to access your GitHub? What specifically are you not being allowed to access? All right. I'm going to send out another poll again. Aaron, double check, make sure you're logged into GitHub normally, and then make sure your credentials are how they need to be. And if any of you run into some problem here where you're not able to follow along with me, you maybe fall behind a little bit. Remember, this is being recorded, but also you can reach out to your team leads during lecture to get specific one-on-one help from them. kind of have this two-tiered attack here where I'm going to lead the class in general, but if you need specific help, you can always reach out to your team leads as well. Oh, great. Looks like Aaron's got it figured out, had to reset his password. That's excellent. All right, so here's another anonymous poll showing up in DS15. I've authorized Google to access my GitHub account. Yes or no? Again, if you don't do this now, you're gonna have to do it before you can work on your assignment. So you'll have to do it by the end of the day at a minimum. All right. Great. I see that most people are caught up, following along with me. All right, I'm gonna get moving then. But keep asking questions if you have them, or if you have something that you think is really weird going on, reach out to your team lead and they could maybe help you troubleshoot a little bit. So try clicking on Martin says, it's not letting me type anything on this page. Try clicking on the search bar there and type in your GitHub username in that search bar. I think the search bar might be a little hidden. And if it's still odd, still doing weird things, maybe just try refreshing the page. Something like that. Kent says it hasn't asked for permission. Then you're probably good. You may have already done this with the pre-course work at some time, Kent. But we'll see. So as long as the goal here is you want to be able to type in your GitHub username, then what's going to happen is Google Colab is going to look for all of your repositories here. So you notice I have a lot of repositories. You're probably not going to have very many. I want you to select the repository that we just forked. DS Unit 1, Sprint 1, Data Wrangling and Storytelling. And then what this tool is going to do is it's going to look through that repository and show you all of the IPython notebooks. These are all of the files that we just looked at before. Okay, good. Martin says he refreshed and the authorization came up. Others, if you're seeing it hasn't asked for authorization, try refreshing as well. See if it just maybe takes a second for it to load. All right. But you can see here, we can see all of the files we're going to need to work with throughout the week. There's 2 files per module. So there's 2 files here for module 1, 2 files here for module 2, 3, and 4, etc. One of those files is the lecture notes, and the other file is the assignment notebook. All right. So I'm going to open up the lecture notes with you here. Notice that sometimes you can't see the full name of the file if it's pretty long, but if you hover over it with your cursor, it'll show up in the bottom of your screen. I don't know if you can see that on mine, but there's that bar at the very bottom. And all of the assignments end with _assignment at the end. So this top one here is the lecture notes. That's what we're going to be working with here for the next hour and a half. Okay. So if you go ahead and click on that, you'll notice, hey, we've got this open in Google Colab. You know, we can see all the text here. We can come down here and write some Python code if we wanted to. We're ready to go. Basically, we've used Google Colab to open a file from our GitHub in Google Colab, and now I'm ready to work on it and make changes. All right. However, there's one more step I want you to do before I would call the file completely ready to go, completely ready to be worked on. And that last step is I want you to come here to File and say, Save a copy in Drive. File, Save a copy in Drive. It's going to open up a new tab here, and a few things are going to change. I'll tell you about what those changes here in a minute. Okay. Edwina shares a screenshot. I love you guys sharing screenshots here, giving good context for your questions. And you'll notice that there's a drop-down menu for the repository. So let me even just think what you're seeing here, Edwina, is you need to make sure that you have the right repository selected from this drop-down menu. It looks like it has the Edwin A. Palmer repository selected right now. Make sure you have the repository for our week of content selected, and then you'll actually see these notebooks down here. For example, if I select a repository that doesn't have any notebooks in it, well, that's just going to be blank. All right, but if I select a repository that has a lot of notebooks, it'll display them and we should be good to go. All right. So click on the very first notebook you see under the repository for this week. That will open up a page like this. Then you're going to say File, Save a copy in Drive. And what that's going to do is it's going to make a copy. Notice we have a little GitHub icon here in the top left. But if I say save a copy in Drive, sorry, my toolbar is here in the way, then it'll take me to a page like this. It's basically the same page, but now it says copy of in the title, and now there's a little Google Drive icon here instead of a GitHub icon. What we have just done is we've taken this file, which was originally from GitHub, and we've made a version of it on your Google account in Google Drive. So now you're gonna have two versions of the files. You're gonna have the version of the files in your Google account, and you're also gonna have the version of the files on GitHub. Now I want to do this because I want you to have a backup of all of your files on Google Drive in addition to on GitHub. If something gets messed up with GitHub, you'll be able to reset your files from the Google Drive versions. The likewise is also true. The opposite is also true. If your Google Drive files get messed up, you'll be able to restore them from the GitHub version. So I just want you to have two separate versions here. And I encourage you to work from the Google Drive version of files whenever possible. All right. So this copy of, I'm going to actually delete that. Okay. And now this should have the same file name as the original file in GitHub. I'm also going to make one more change to the title of the file here. You do not need to make the change that I'm about to make. So just watch me do this. I'm going to say DS15 here. You don't need to do that. The reason why I'm doing that here is because this is now going to be our lecture notes, all right? And I'm going to share these lecture notes with you, all right? You don't need to do this. I'll just do this as the instructor here. I'll copy this link, all right? And that link I just shared will be useful to you on into the future, right? So that big old gnarly URL there, that is the link you will use for accessing our lecture notes from here on out. All right, so any changes that I make to this file, they should be automatically reflected in that link. You should be able to see the changes that I've made. Now, if I've made some changes to this file and you're on that same page as I am, the DS15 page, that's how you know that this is the lecture notes, right? If you're not seeing all the changes that I've made, you might need to refresh the page. Sometimes those changes don't show up immediately. You might need to refresh the page to see them, right? But what I'm gonna do is I'm gonna write a whole bunch of code here with you later on. And then if you need to refer back to it when you're working on your assignment this afternoon, you could use that link that I just shared. So what I'm also gonna do with that link, and I won't do this every day, but I will do it for today, is I'm going to pin that link to the top of the channel in Slack. All right, so you'll notice here that what has happened is this gets lit up as yellow, all right, and it gets added to these pinned items. All right, so you can see our Google Calendar. If you're interested, take a look at that if you haven't yet. But also our very first link to lecture notes, I'll pin that to the top of the channel. I'll probably unpin this after a couple of days, but this is one place where we'll store, trying to keep track of really important links, since we'll have a lot of chatter and discussion here in the DS15 channel. Sometimes it's hard to find important things. So I'll pin that here for you for today so you can access that this afternoon if you need to. All right, move my Slack back over to my other screen. Okay, and now we've done the first step. We've taken a file that was in GitHub and we've opened it in Google Colab. Now I want to show you how do we take this file and save it back to the Google Colab version. Excuse me, how do we save our changes back to GitHub? All right, so I'm actually going to delete the GitHub version here. I'm going to close this tab, and I'm only going to work from the Google Drive version. And I'm just going to make a silly change here. All right, so I'm just going to add a text cell, and I'm going to say, this is a change that I am making to the file. Right? Because in order for us to save our changes back to GitHub and know that they're working, well, we actually need to have altered the file in some way, or else we're just going to be seeing the same version as the original, and it'll be hard to know if we really made a change, right? So I just added a text cell here, and I typed in that text cell, this is a change that I'm making to the file, and I'll put a period on it. All right. So I've made a change here. Imagine that this change wasn't just a simple change. Imagine this change was you doing your assignment work in the afternoon. You made a lot of changes. You did a lot of hard work, and you want to get credit for that hard work. Well, now that you've made those changes, these changes will persist in your Google Drive, right? You'll have those in your Google account forever and ever for you to reference. but you need to now update the GitHub version with those changes. So what we'll do for that is we'll say File, and then save a copy in GitHub. All right, File, save a copy in GitHub. And we'll see a pop-up here very similar to the one we saw before. And you have to make sure that the right folder here is selected. That should happen somewhat automatically. But we also want to make sure that this file path is correct. And I'll tell you right now, this file path is not correct. Right? If I save this to this current file path, what it's going to do is it's just going to put it in the root of my GitHub repository. However, when you're working on specific days of content, you probably want to save things to your individual, to that day's folder, to that module's folder, right? So grab the title of that folder's, grab the folder's name here and add that on the front of the file path. Okay. Now this file won't just be saved in the kind of in the base, the top level of the repository. It will be saved within this module 1 folder. All right. Now it doesn't really matter exactly where it's saved at within the folder. I mean, if you want to keep your files organized, I recommend updating this file path. However, if you save things even in the root, if you forget to change that file path there, there's the Lambda School shop. If you forget to change that file path, it's not going to be a disaster. The team leads will still be able to find your work. All right. But that is basically what you'll need to do in order to save this back. Now I can add a commit message. This commit message is just a little note for myself explaining what I did when I made these changes to the file, right? So I'm going to say, makes a simple change to demo saving work to GitHub. Okay, that's my commit message. This is letting you know if future me comes back and wants to know, okay, why did I save to GitHub? What were the changes that I made? Have a short description of what I did here. All right, and you can check the include a link to Exploratory box if you like. I'll show you what that does here in a minute. But you could have it either way. You could have it checked, you have it unchecked. It doesn't matter the whole time. Okay, so I'm gonna hit OK. And what this is gonna do is it's gonna think for a second. It's gonna go and it's gonna make the changes on GitHub, and then it's gonna show me the changed version on GitHub, right? So notice I'm back here on GitHub. I'm in my account. I'm looking at my forked version of this week's files. I'm within my module 1 folder because that's where I saved things. Remember, I updated that file path, and now this file should have the changes that I made. This is a change that I'm making to the file. All right. So the process I just showed is basically what you'll do every single day as you're working on your assignments, right? You will find the file that you want to open, and you can go either to collab.research.google.com/GitHub. So you might want to bookmark this URL here. You might use it often. Select the file you want to open. Once you have it opened in Google Colab, you're going to make a copy in Drive. All right, save a copy in Drive. That's going to change the file name here. Then you can tweak the file name if you like, set it back to the original. Because remember, it adds copy of at the beginning. You can delete that copy of. And then go ahead and do your work, make your changes to the file. And once you're ready to submit your assignment, once you're ready to save your work back to GitHub, you're going to say File, save a copy in GitHub. Then as you do that, you can update the file path, you can give yourself a commit message, etc. When you hit OK, then it will go and actually make the changes in GitHub. All right. So a little bit of a complicated process. All right. A little bit of a complicated process. Aaron says, well, we need to add our name as we did in submitting the pre-course work. You will. I'll show you where to do that here in just 1 second. All right. By and large, your team leads are going to just over time have your GitHub usernames memorized. So they'll be able to use your GitHub username to identify you. But there is a place where we can, where you can add your name here in a second. All right. But that is by and large the process. We have a file on GitHub we want to use. We open it in Colab. We make changes to it. We save those changes back to GitHub with a couple other little more complicated details along the way. All right. Okay, so I'm gonna demonstrate one final thing here. But before I do it, I want to emphasize one other point that I haven't brought up yet. So Forking the repository, remember we made a copy of the Lambda School version to your individual accounts. You only need to do that once per week. You only need to do that on Monday, right? Once you've forked the files, you'll have them all week to work with, right? So you only need to do that once per week. However, the other parts of the process I showed, opening a file in Colab, making changes, saving them back, you're gonna need to do those at least once per day, maybe multiple times per day, depending on how often you want to submit your work or update your work, all right? I'm gonna show you one other thing here with GitHub that you'll need to do. However, this last thing I'm gonna show also only needs to be done once per week, all right? Let me show you what I mean. So what we're gonna do is, after we have made some changes to our files here, you'll notice it says, this branch is one commit ahead. That means I've saved these files one time, and now they're different than the Lambda School version of the files, right? I've made one save, and now these files are different, right? You can even see my commit message right here. Makes a simple change to demo saving work to GitHub, and it says, oh, files in this folder were changed 3 minutes ago, right? So it's telling me information about when I made these changes. There's one other thing I want you to do. The final thing I want you to do to submit your work for the week is to open up a pull request, all right? Now remember, a pull request, as I mentioned a little bit earlier, is a way that we could say, hey, I've made some changes to these files. I think it would be cool if they got incorporated into the master version, right? So the difference here is you're going to open up pull requests to submit your assignments. However, we're not actually going to merge your changes into the Lambda School master version, because if we did that, we would be, adding all the answers to the main version, right? We want to keep that Lambda School version clean and empty, so that future groups of students can use that as a starting place for their work during the week. But we do want you to add a pull request to your repository. So I'll show you what I mean. And this is where I mentioned you can add your name, as Aaron asked, right? So if you open a pull request here in the pull request tab, notice I'm here on my copy, and I hit new pull request. All right, then it's going to go and it's going to look at all the different changes that I've made, and it reports back to me, okay, there's some changes that were made here on April 6th, and these are the ways that these files are different from one another, right? So it's showing me the differences down here, but don't focus on this code down here. It's going to be not very intuitive. Basically, just notice that this is saying what the differences are between the two versions of the repository, between my copy and the Lambda School version, right? So I'll hit the create pull request button, and here I can add my name in the title of the pull request. I'll say Ryan Allred, Unit 1, Sprint 1, assignment work, or something like that, right? So do add your name here. Make it a little bit easier for your team leads to know who you are. Yet again, they will be able to see it from your GitHub username. So if you forget to add your name here, it's not a disaster. And then just give maybe a little snippet about what you're doing, right? This is Unit 1, Sprint 1. And then I'll say create pull request. So it's click a lot of green buttons, give it a title, right? And then it says this base has no conflicts with the base branch, right? So what this means is I could merge this with the Lambda School master version right now. You guys probably will not see this green button here. I'm seeing this green button because my account is an instructor account, and I actually have permissions to merge changes into the Lambda School version, but your guys' accounts don't have those permissions. So you probably won't be seeing this final green button here, right? But at this point, the pull request has been opened, it's ready to go. And I'll show you why that's valuable, right? So if I come back here notice I'm on the Lambda School version again, and I click on the pull request tab, okay, you can see here's my pull request, right? So the value here is team leads can come to the Lambda School version, and they can very easily find your specific repository, right? So I could easily go and look at David Cruz's changes that he makes as the week goes on, all right? The thing I'll mention here is that you only need to do this once per week at the beginning of the week, all right? Once you have submitted a pull request, any future changes that you make to your repository will automatically be added to that pull request, all right? So you only need to open a pull request once, and then any changes you make will automatically be added to that pull request. So typically, by the end of day on Monday, will want you to have done some work on your assignment, made some changes back to your GitHub repository, and opened a pull request by the end of the day. And then the team leads will use that pull request to go and find your files, find the changes that you've made, and give you feedback on your work. All right. So there's definitely simpler ways of sharing work with one another. There's definitely simpler ways of sharing files with one another. But this process that we're making you suffer through a little bit is industry standard. You'll be using this process heavily on into the future. So at later points in the curriculum, you'll be working on group projects, and you'll have multiple fellow students all working on the same folder of files, the same repository. And you'll need to use this process so you don't override one another's work. And so you make sure that one of you doesn't mess up the whole set of files for the others, right? So try and get you aware or somewhat comfortable with it now. We've noticed we've been using the browser for doing all of our work, right? We've been clicking on buttons and using this graphical user interface for making all of our changes. Later on in the course, we will show you how to work with GitHub using what's called the command line interface. So here is my command line on my machine, okay? This is basically a little window I can open up so I can interact with the files on my computer. All right, so if I type ls, it'll show me all the different things I've got going on here, right? And I can type in these little commands for making small modifications to any of the files on my computer. Later on in the course, we will show you how to use GitHub from the command line, which this is even more of an industry standard, being able to do this. But we don't want to overwhelm you with kind of new processes and new tooling on the first day. So for starters, we're just going to stick with the browser, just as we get going here. Yeah, I like I like Sonic the Hedgehog. Okay, so I have Sega. I've got a Sega emulator on here anyway. So, alrighty. So I hope that's a good brief overview. As you go to do this same process this afternoon, you might get stuck. You might kind of forget some of these things here. Refer back to the lecture video, and also feel free to ask any questions in the DS15 channel. All right. So we're going to take a quick break here. We're going to take a 5-minute break. And when we come back from that 5-minute break, we're going to actually use this file that I've made to write some Python and do some exploratory data analysis. So thanks, everybody. I'm going to turn on a 5-minute timer here. I'll see you back here in 5 minutes. All right. Okay, come on back. And now when I say come on back, hopefully that means you're just, back from getting a drink, using the restroom, whatever you did during the break. Even just resting your brains. These calls get a little bit long. It's good to break it up a little bit. Now, when you do come back, I want you to make sure you turn your video back on. All right. We want you to have your video on at basically whenever you're on a video call here at Lambda School. Now, the reason for that is not because we're surveilling you and like watching what you're doing and like want to make sure that you're paying attention. That's not the reason at all. The reason is just if you have your video on, you're less likely to let yourself get distracted by your phone. You're less likely to, leave the room for whatever reason. I don't know. It's just, it's a small little commitment device of helping you be more attentive, more locked in, more focused with us. All right. If your video feed is not on, we assume that means you are away from your machine, that you're not with us in lecture. And so if we see that a lot, team leads might go, hey, is there something we could do better to help the lecture experience be better for you? Something like that. We do want you to have your video on as often as possible. Even if you're eating, right? Just don't chew with your mouth open or something like that. Even if you've got, kids running around behind you, doesn't matter. We all are doing this from home, and all have lives. So don't worry about stuff like that. Alrighty. So now that we're back, I'm gonna go ahead and share my screen. Check Slido. All right. Can we / should we post our Stack Overflow questions on Slack to get help / feedback from our peers? What about Colab notebooks when we get stuck? This is a great question. So we've actually set up a tool that will make it so whenever you ask a Stack Overflow question in our Lambda School Stack Overflow instance, with the right tag, if you put in the Unit 1 tag there, it will automatically post your question to our DS15 channel. I'm not 100% sure if we have that completely up and running yet today, but I'll check with the team leads and we should have that going. So you shouldn't need to post your Stack Overflow question to Slack. That should be done automatically. But one thing that can be helpful is if you want to give somebody else context for the problem you're running into, screenshots are helpful. Copying and pasting code snippets or error messages is very helpful. Like worst case scenario, you can just share the whole link to your Colab with somebody else, and they can then really dive in and get an idea of what's going on. So yeah, short answer here is yes, all of those things are great, but you shouldn't need to do the Stack Overflow thing. That should happen automatically. All right. Is LSDS 111 exploratory data analysis the correct file? Yes, it is. That's right. Do you recommend pre-forking all the lessons for the track just to avoid having to do this every week? No, I do not recommend doing this. All right. So the reason for that is I am working ahead of you as a kind of a curriculum writer and as an instructor, and I am likely making changes to the Sprint 2 content, the Sprint 3 content, and it's going to be changing all the time. So if you fork everything right now, I then may go and make changes to it, and you're going to have an outdated version. So I recommend just fork at the beginning of the week every week. That way you'll make sure you have the most up-to-date and current version. So it's kind of a pain to have to remember to do it every week, but that will prevent what are called merge conflicts. A merge conflict is when you make changes to a file and I make changes to a file and they conflict with one another. And they're a big pain to deal with when you're working with IPython notebooks. So I recommend just fork at the beginning of the week. Is PowerShell the same as CMD? Yeah, that's kind of the Windows version of the command line here. And we'll talk about that more in the future. But yes, they're very, very similar. They're not identical, but they're very similar. Are we doing a pull request every week? Yeah, so once per week, you're going to fork the repository and submit a pull request. You probably do both of those things towards the beginning of the week. But yeah, you only need to do a pull request once per week. When is the earliest in the week, Sunday / Monday? Do you recommend working on / forking the material? You can fork it 5 minutes before lecture starts. Sometimes even the hour before lecture starts on Monday morning, I'm making changes. So you're not really safe forking it until like till the minute lecture starts, which I realize is probably kind of annoying, but I do sometimes like to make last minute adjustments to some of our files. So, oh, and Annika says the Stack Overflow integration is up and running. That's fantastic. That's fantastic. We'll probably talk a little bit more about that tomorrow. So if you look at our calendar, remember that's pinned to the top of the DS15 channel, you'll notice we'll have 2 Q&A sessions every Tuesday and Thursday afternoon. And those will be times where we can talk about some more of these housekeeping things. We can talk more about Stack Overflow. There's another thing that's going on with getting all of you set up with Lambda School email addresses, and then some other security things. We'll talk about more about that in the afternoon, but we actually have a lot of other Python specific lecture content to talk about right now. So I'm going to defer some of those things till a little bit later. Oh, Annika says to make sure that your Stack Overflow question gets put in our channel, use the DS15 hashtag. Great. Okay. Great questions. Love your questions. Keep them coming. I'm going to clean up some of my tabs here. Things that I don't need to have open necessarily anymore. All right. And remember, anything that I type here during the second half of lecture, you should have it as lecture notes in the link to the notebook that's pinned to the top of the DS15 channel. All right. So I recommend at this point, go and get one of these files open and follow along with me. You know, the more active you can be during lecture, typing along with me, keeping up with what I'm doing, the better some of these things will sink in, the better you'll be able to concentrate and just stay engaged with the lecture. So do try and follow along with me if you can. All right. You'll notice here at the top of our lecture notebook, we have our objectives for today. Every day of content, everything we do here instructionally at Lambda School is focused on these objectives. All right. So, you notice we've done objective 1, can submit assignments via GitHub, and we got 4 more objectives to go through, which is kind of a lot here for the next hour. But because some of these things are a review from the pre-course work, we're going to go through them a little bit quickly, and they hopefully won't be too bad. All right. So first objective here, we have already gone through this, and you'll notice I have a lot of text here that I've tried to explain as well as I can with just the written word, all the process that we did here in the first half of lecture with some screenshots, some explanations. That's here for you to reference. We're going to focus here on objective 2, load a data set, a CSV file from its URL. And what we're going to do is we're going to use data sets from a specific website today. And that website is called the UCI repository. UCI stands for University of California, Irvine. And they have a lot of useful data sets here that we're going to use. We'll use these a lot more heavily at the beginning of the course. These are really common data sets used by people who are just getting started with data science, just learning about some of these things. So you'll probably get sick of hearing about the IRIS data set here before too long, right? And you're going to use some of these data sets on your assignment as well. All right. Now, these are the most popular ones, but there's actually a whole bunch of them. If you click view all data sets here, there's around 500 data sets. We're specifically going to use the flags data set here at the beginning of class. All right. I'll link you specifically to the flags data set page here. All right. And step 1 before you load any data set is learn as much as you can about the data set. How many rows should it have? How many columns? What are the column headers? Is there some kind of what's called a data dictionary, which is an explanation of what the different columns of that data set represent? Are there missing values? Is there missing data? And one of the best ways to get a feel for some of these things is to open the raw file and just look at it. And that's another way of kind of making yourself aware of some issues you might run into as you try and read in that file, as you try and import some of that data. All right, so we're going to do some of this step number 1 here from the UCI page. You notice it says 194 instances. That means 194 rows of data. Should have 30 columns. All right. It says there's no missing values here, so that's good. It's something we don't have to worry about with this data set. And then the data dictionary is kind of down here. This attribute information. This explains what the 30 different columns of this data set each refer to. All right. So the last thing I'm going to do here is I'm going to look at the raw version of the file. Now, there's a couple of ways to do this. The first way is go ahead and click on this data folder, and then flag.data is the file that we actually want. So this is a CSV file, comma separated values, but it has the file suffix .data. That's a common thing here with UCI. Don't let that throw you off. It's still a CSV file. But if I right click on flag.data and say copy link address, that will give me the URL to this file, right? If I click on this link, it's just going to start an automatic download. Boop. Notice, and that downloaded the file to my machine. I don't necessarily need to have this automatic download. As long as I have the link to the file, I should be able to work with it. So again, right click, copy link address. All right. Then I'm going to show you a way here programmatically. So the link address we just copied is the same as this flag data URL. So it's already in the notebook for you. All right. Let's see. Aaron, I'm not sure if what's going on with your connection there. Everyone should be able to access this page. If you have some kind of a ad blocker or some kind of extra security features on your browser or other things like that, you may run into some issues today. Even Colab sometimes will not work correctly if you have an ad blocker up and running. So when you're working with Colab, you might want to turn ad blockers off. And it's going to be a pain. You'll have to turn them back on to get the benefits from them later on. But there might be some kind of security setting or ad blocker that's causing you to not be able to see that page. Okay. But I hope you all have the URL here. All right. And I'm going to take this and I'm going to put it as a string. So I'm going to put these little quotation marks around the URL and save it to a variable. That variable here is flag data URL. All right. Alrighty. Now, we're going to do something here, which is a little bit interesting. So this line of code right here, this curl command, this is actually not Python. All right. This is what we call a bash command. This is as if I was running this same command from my command line tool, whether the command line here, if you're on a Mac machine or PowerShell or something like that. If I type this same curl command, it's actually probably not going to work for me. It's not liking the SSL certificate. Maybe UCI's SSL certificate is having issues, which is likely why you got that problem there, Aaron. So it might not be on your end, might be on UCI's end. We'll see if we can get this to work. Yeah, so the curl command here is not liking what's going on because of that SSL certificate. We'll try it here in the code cell. See if that'll work. Yep, not working there either. All right, so typically this will work. Let me show you a different example of this. This will typically output the contents of the file directly below in this output section. So we have the code cell here. That's everything that's being typed here. And then the output section, oh, excuse me, did not want to add that code cell. The output section here is typically where we'll see the contents of the file outputted. Let me just quickly go and grab another file just to demonstrate this for you. On my GitHub, I have a whole bunch of data sets that I sometimes use during lecture. We might even use this adult.csv one here a little bit later. I click view raw. Notice here's the raw version of the file. I can copy this link here, and I can use that the same way that I use the UCI URLs, right? So let me just show you. Here's the adult data set, but I shouldn't have an SSL error here with GitHub, right? This is what it would have done with the flags data set. Outputs the contents of the file, and then you can look at this and so notice, okay, are there any irregularities with the file? We'll practice this actually a little bit later as well. In order to get around the SSL issue, and actually, by the way, I'm going to clear this output here because the adult data set is really big, and so it's like making it really hard to scroll in my document here. You notice that? So I'm actually going to go ahead and clear this output. And I hope that UCI gets that security issue addressed. All right. That's probably not on our end. All right. So this is just an example of one way we can look at the raw version of the file. But a second, more fail-proof way that doesn't depend on SSL certificates is you could just look at the downloaded version. If you click on the flag.data, right? And you might need to pick an application to open this with. All right. I'm going to just use the text edit. If you're on a Windows machine, you could use Notepad, or if you have some other kind of text editor downloaded, you can use that. All right, this is just a second way of looking at it. Now here's the flag data. This is exactly the same thing we would have seen in the output if we use the curl command, and it looks like it's worked for some of you. Anna says it worked for her. That's awesome. Not sure why we're seeing so much inconsistency here, but either way, it's good to have multiple ways of doing it in case one of them has issues like what we're seeing here today, right? So as I look at this file, it looks pretty good to me, right? So each row here is going to be a different row of our data set, and then each value separated by commas shows us the different columns, right? So the first value of each row is the country name, and I'm not sure what all the other values refer to. It looks like we've got colors here, green, black, green, etc. Now, if we look at the data dictionary here, it'll tell us what those things are. So it looks like the second column is an integer value representing what continent or landmass this place is, a zone, which is some kind of like a time zone, quadrants, area in thousands of square kilometers, right? So the fourth value should be pretty big. Area in square kilometers, area in square kilometers, area in square kilometers, etc. Right? So you look at the raw file before we've loaded it and know that, okay, this file looks pretty normal. We shouldn't have too much trouble. Oh, and that is true. So Jace mentions if you're using it in the command prompt, both Windows or Mac, you will need to take this exclamation point off. This exclamation point is called a bang character, B-A-N-G, like, you know, bang, a gun went off. And what this character is doing is in our IPython notebook, this says to the notebook, this says to Google Colab, hey, this line of code I'm putting after this is not Python, all right? This line of code that I'm putting after this is a shell command, a bash script, right? And you can learn more about this process. It's sometimes called shelling out. And there's a good link here more about how to use shell commands within IPython here at this Jake Vanderplas document, right? By the way, this whole Jake Vanderplas Python Data Science Handbook is excellent. Be a very helpful resource here as we're going through some of the things that we'll be talking about this week. So please do take a look at this link. I think you'll find it interesting. A lot of good stuff here in that Python Data Science Handbook. All right. So yeah, you will need to take the exclamation point off to try it in PowerShell or to try it in your command line. All right. But we've confirmed now. We've done step one. We've learned as much about the data set as we can. Now we're going to actually try loading it. And we may see some other issues as we try and load it, right? So I'm going to import the pandas library here, which I'm going to use to import it. I'm going to save this to the variable df. df stands for data frame. And it's a really common just kind of beginning variable name. It would be better to like give this maybe a more intuitive variable name like flags or something like that. And maybe that's even what I'll do today. I'll give this the variable name flags instead of df. But I want to use pandas, right? So I've imported pandas and given it this variable name PD. So I'm saying, hey, from the pandas library, use the read CSV method, and then grab the file that's in the flag data URL that we saved up here above, right? And then we're gonna use the .head command to look at the first 5 rows of the file as we've imported it. Oh wow, it's really having troubles here due to the SSL certificate. Let me see. Okay, so I'm gonna have to be a little bit creative here. That's a different Zoom call from earlier. Do not follow along with what I'm doing right now. I'm gonna try and make it so we have a URL that we can use. Hmm. So basically, I'm going to use GitHub from the command line to update the data set that I have. It's going to be a lot faster than using the browser version, but it's something that you don't need to know for today. I'm just going to try and make sure we have a data set we can actually load via URL here. So here's my datasets folder, and I want to paste in the flag data set here. I'm going to rename it flag.data. And then this is how you would update. This is how you do save to GitHub from the command line, all right? Git status, git add, give a commit message here, and git push origin master. Okay. So the process I just did from the command line is like the same process you guys do when you say file, save a copy in GitHub, but it's kind of with this somewhat, a little bit scarier version. Oh, you can just void the SSL? That's all right. We're probably already at a point where you can work with this. All right, so now I should see the flags data set in here, flag.data. All right, so here's my data sets folder. And what I want you to do for getting the URL from here is click flag.data and then click this raw button. If you want to grab a CSV from a GitHub repository, you always need to make sure you're working with the raw version of the file, right? So this is the URL we're going to use as we kind of have to pivot here. I'm going to change this. We're actually not going to use the UCI URL. We're going to use the GitHub URL, which I think is a lot closer to what we did during the, there. Now my curl command works. I think this is a lot closer to what we did during the pre-course work anyway. Okay. And now we have that data set there. So you can use that raw.githubuserconsent.com link and replace the flag data URL with that, and we should be good to go. All right. And also maybe it was interesting to see me very quickly do things from the command line. All right. So as we look at this file that's been read in, do you see anything that might be wrong with it? You can go ahead and just type directly in Slack. Sometimes I'll ask questions here during lecture, and you can just trying to make you think about things or prompt you to think about things. Do you think this file has been read in correctly, or do you see anything that might be wrong with it? Also, even if somebody else has already said the same thing you were going to say in Slack, go ahead and keep on typing, or maybe just emoji respond to something somebody else has said. That's cool too. Yeah, but I do want as much participation as possible. Again, just one way to keep yourself engaged here during lecture. All right, so I've seen a lot of people noticing they've got problems with the column labels here, the column headers. You notice this top row here has this bold font to it. It's supposed to be the headers of each column. All right, and so we actually don't have column headers here. Yeah, the header's missing. So what's happened is Pandas has read in the first row of data as the column headers. It thinks that whatever the first row is should be the column headers. However, you'll notice with our raw file here, we didn't have any column headers in the raw file. We just had the data. All right, so what we need to do is we need to tell Pandas that we want to use different column headers. All right, so what we're going to do here is we're going to look at the documentation here for Pandas read CSV and try and figure out why things have gone wrong, right? So we talked earlier today about the 20-minute rule and taking those 20 minutes to try and solve your own problems. One of the best ways to do that is to read documentation, all right? The documentation is going to be scary here at the beginning. It's going to be confusing, but it is a super important skill that we build throughout our time here to not be afraid of code documentation. So let me show you what I mean. If I open up a new tab here and I Google Pandas read CSV, okay, it'll take me to the Pandas version 1 documentation. All right. So here is all the documentation about Pandas read CSV. There's a whole bunch of information about how this function works. All right. And now what's going on here is this whole mess of stuff here tells us all of the possible parameters that we could pass to this function. Notice right now we're only passing file path or buffer, right? And they've got it written in a very confusing way here, but right now that's what we're passing. We're passing our URL, the file path, all right? But there's all of these other things that we could also pass to the function if we wanted. If we wanted to change the way that we read in this file and do it in a maybe slightly different way. All right, so one thing we can do here, and I'll just take you straight to it. It's just out of a matter of time, but I encourage you, if you run into issues like this on your own, pull up the documentation, practice reading through this, right? Each of these bolded items here is a different parameter we could pass, all right? And you'll notice the header here is what we're having problems with, all right? It says row number or row numbers to use as the column names and the start of the data. The default behavior is to infer the column names. If no names are passed, the behavior is identical to header equals 0, all right? So we could tell pandas which row of data should be the column headers. All right, so I could say, I'm gonna read this in just the same way I did before. I don't need to import pandas again. I only need to do that once in my notebook. As long as I've run this line once, I should have pandas for the rest of my time, right? So I'm gonna say flag data URL, and I'm gonna say header equals 2, okay? What this is gonna do is gonna take the second row here, American Samoan, it's gonna use that as my headers. Oh, never mind, it took Algeria. It took Algeria. Because I guess this is row 0, row 1, and row 2 in the raw data, right? So now we got Algeria as the head, and we actually don't even have anything above that. Albania and Afghanistan, they've all been thrown away, all right? So the point here is, this is not the functionality that we want, but the point here is we could use these other parameters to look at the documentation to get an idea of how we might modify our code, all right? Now, one of the ways of looking at the documentation is exactly what I did. Just Google pandas and then the name of the method or the function you're working with. In our case, it was read CSV, all right? But there's a couple of other ways of pulling up documentation. The first one here is to type the help command and then type pd read CSV directly into a code cell and then run that code cell. All right? This will output the same documentation that we saw here on the pandas page, but it puts it in the output of the code cell, all right? This is one great way to do it. It's kind of in line. However, this is all just kind of plain text. We don't get any of the bolded text or some of the same text formatting you get here on the same page, right? There's no pink information. So you lose a little bit of visual cues here, but definitely still something you could do. I'm going to go ahead and clear this output here because it gets kind of long. All right, that's just going to delete the output section here. Add another code cell, and you can also use question mark and then pd dot read CSV. This is another way of getting at documentation, but this pulls up the documentation in kind of in this sidebar, all right, rather than in the output of the code cell, and it's I don't know, still usable, still readable. All right, we do get a little bit of coloring here in the function signature, right? So both of those are also acceptable ways of looking at documentation. You're going to commonly see me. I'm just going to straight up Google it and pull open the web page because it just is a little bit more readable to me. And for me, it's basically just as fast as using those other two commands. But it's up to you. You could use try the different versions and see which one you end up liking the most in your own workflow. All right. Okay, so Jacob says also the values registers floats as integers. Yeah, that's a good point. So notice here in the column headers, we had a column header of 2, right? And we were supposed to have 2 here as well, but in order to avoid repeating it, it put 2.1. So it doesn't. So it was trying not to repeat column headers. Basically, we need to do something completely different here to fix these column headers. Now, what I'm going to do, I'm going to copy this down below. All right. I'm going to take out header equals 0, and we're going to find out, okay, what parameter do I really need to use to fix this problem? All right. Let me actually close some of these pages that we don't need anymore. Okay. And if I scroll down here, you'll see there's a names parameter. List of column names to use. If the file contains a header row, then you should explicitly pass header equals 0 to override the column names. Duplicates in this list are not allowed. All right, so I want a list of strings that are my header names here, right? So I'm going to say column headers. That's going to be a variable here. I'm going to pass a list of strings here. Now, where would I get the list of column headers from? Well, I would probably look at the UCI flags page, right? And go, okay, column header 1, that should be name, right? Name, and then landmass, then region, right, etc. However, that's kind of tedious to type all this out. This may be something you need to do on your assignment, and I apologize for the tedium. It's kind of just the breaks when you're using a UCI data set. However, I mean, I have some pre-written notes here. I'll just share with you all the column headers here already typed out, and that's what I'm going to use. All right. So here's the column headers typed out. Now notice as I read this in, I'll need to say names equals column headers. All right, so I'll use the names parameter, and set that to the variable, the list that holds my column headers. And that should address the issue for me. All right. Now these column headers, they get assigned from right to left, right? So bot right, then top left text. They started over here on the right and got assigned to the left. If I had accidentally missed 2 of these, just as an example, say as I was typing out, I just skipped 1. What happens here is my row index changes. Notice these are bolded here on the left-hand side. This tells me, hey, I missed 2 column headers because these Afghanistan and this should be the name and this should be the landmass. Notice shifted, it's off by 2. That tells me I've accidentally missed a couple of the column headers. So that's just a little tip if you need to debug the column headers. You should see, for the row index, you should see integer values here in bold. So start with 0, 1, 2, 3, 4. Those are the different identifiers for each row of your data set. If you're seeing something other than these bolded integer values, you might be missing a column header. All right. But that's it. That is how we load in a data set from a CSV, right? The biggest thing is find the link, right? Now, again, clear this output. Find the link that you can use in order to look this up. Now, if you're using UCI, it's a matter of open the data folder, then right click and copy link address. And if you're using GitHub, you'll need to navigate to that file and then make sure you click the raw button to be using the raw version of it. All right. Now we're going to be using the UCI repository in the afternoon for the assignment. So we may need to do some tricky things in order to help you get over that SSL certificate, but I'll get that figured out during lunch with the team leads. All right. But that is, as you'll notice, a conclusion here to objective number 2. Student can load a data set from a URL using pandas read CSV. All right, next, I want to show you how to load a data set not from a URL, but from a local file on my machine. And this is going to be very similar to what we did before. However, instead of using the URL, the flag data URL to read in, I'm just going to upload the whole file to Google Colab. All right, so you're going to need a little code snippet here to do this. And I'll paste this in Slack as well. All right. From google.colab, import files. Now, I don't recommend you trying to memorize this code snippet. I still have to copy and paste it from notes or Google it often. It's not really worth memorizing, but it will be helpful. All right. So here, if I run this code cell with this code snippet in it, all right, it's going to bring up this prompt to choose a file. I click choose files, and it's going to let me pick a file from my machine, right? So I want to go to my downloads, and I want to get that flags data set that I downloaded earlier. All right. And as I upload that, you'll notice it gets uploaded, the cell stops running. And if I click here on this file icon on this left-hand side, it will show me I have flag10.data has been uploaded to my Google Colab. All right. There is a second way of uploading files here. If you don't have to use this code snippet, you could also just click on the file icon here and then click the upload button. It would do the same thing. All right. So we'll call this uploading using the graphical user interface. Okay. But because I uploaded the same file, it didn't override it. Sometimes you can hit refresh here if you're not seeing the file that you like, right? By the way, you do not need to mount your Google Drive. Don't worry about this step. Kind of just ignore that for now. I think a lot of students sometimes get confused about that. All right. But that's the second method here. Use the code snippet or use the sidebar. Now, I tend to prefer the code snippet. And you may say to yourself, why do you like the code snippet? This looks like ugly, unintelligible code, whereas this process is very intuitive. I like the code snippet because if somebody else is using my file, they know based on this code snippet, hey, from this point onward, if you want to run any of this code, you're going to need this file, right? And the code snippet is kind of a reminder to them that at this point in the process, they need to have a file to upload, or else stuff's not going to work for them. So yet again, this is just another matter of preference type thing. You can use either method. All right. But at this point, now that I have that file uploaded, I want to read it in. So I'm going to use the same variable flags. This will override what I used before. I'm going to use pd.readcsv. But now instead of the URL, I'm going to use the file name, which for me was flag10.data. Right? You might not have the 10 here if you downloaded it a different way. You might just be flag.data. That's because I've downloaded this file 10 times to my machine. All right. And then I still want to have the names be the column headers. Because no matter how I use it, this raw file still doesn't have column headers. Then I'll use .head command to look at the first 5 rows. And that has worked as well. Okay. So that is objective number 3. All right. Use the code snippet or use the GUI to upload the file to your runtime. And then instead of using the URL, just use the file name here as a string. All right. Not too bad, not too bad. Okay. So our last objective here, I guess we have 2 final objectives here, is we're going to dive into pandas, right? Now we talked about uploading files. Let's actually do some of this fun stuff. Julie asks, where's the flag data located? I'll show you here. So here's the UCI page. Then click on the data folder and use flag.data. That should download the file. Notice it just downloaded flag 11 to my machine. Or you can go to my GitHub. Here in the datasets repository. Remember, repository is just a folder of files here. So here's a folder of a whole bunch of CSVs. And then you want flag.data. To get the URL, you probably want the raw version. So this is the URL that you'll end up using if you're reading it in from GitHub, as opposed to the UCI website. Okay. Well, typically here at the beginning of the class, we'll be using UCI, both UCI and GitHub to demonstrate some things, right? But I'm going to go and I'm going to grab a different data set here. All right. To demonstrate some things here for our last 2 objectives. I actually don't want the flags data set. I'm going to use something called the adult data set. It's a very popular data set here on UCI. You'll notice, if I can get back to the home page, it is the 2nd most common data set. And the number here on the left is the number of times it's been downloaded. It's been downloaded 1.7 million times. All right, so this is a very common data set used for demonstrating some basic data science skills. All right, so if I click on adult here, I'll share the same page with you. Jay says there will be a video of this session afterwards, right? So I can go back and look at it. Yes, absolutely. Everything I'm doing here is being recorded and should be available hopefully before the end of lunch. After this lecture, we're going to take a 1-hour break for lunch. All right. So yes, it will be available, right? But anytime I work with a new data set, remember, what are the steps I want to do? I want to make sure, be aware of the number of rows it has. This has 48,000 rows, almost 49,000 rows, 14 different columns or 14 attributes. And it says, yes, this one does have missing values. So that's something we'll have to think about. And here's the different column headers, list of attributes. Right. Now, this is census data from the 1994. All right, so this is information about people that was collected in the census. And we're gonna do some things here with this data set. So I need to check if I don't use the UCI version here. I wanna make sure, now there's some problems with the UCI version, which is specifically why I wanna use it. I believe I have the adult data set here as well. Oh, stupid iCloud. Oh, that's annoying. Okay, let's do this. I'm gonna have to upload this again. I'm gonna have to do the same thing I did with the flags data set here. So bear with me one moment. And I'm gonna paste this in. And I'm gonna rename this adult original data. All right. You wanna be using adult original and not adult. All right. And I need to make it so that this whole folder of files does not get saved to iCloud. But I'll go do that later. Okay, so those files should be fixed. I'm just navigating through my files here. I'm in the datasets folder. I'll check for changes to that folder. You notice all the iCloud stuff has been changed. I'll get all those changes ready to be pushed up to GitHub. This is my commit message, just like we would put in GitHub. Fixes files, adds dirty version of adult dataset. Sorry. I need to put git commit -m. You'll be doing this in a couple of months. Okay, now it's all ready to go. Push that up to GitHub. Okay, it says that it's working on it. Great. Back here, my data sets. Looks like I've had to fix iCloud issues in the past, which is a pain. And we want flag. Where's the other flag data set? Oh no, we want the adult data set. Has this not been fixed? There we go. So we've got adult original. That's what we want to use here today. So I'll share with you this raw link because UCI is having issues. All right. That's the one we're going to use right now. Okay, so this is actually not the link that you want. You want to use this link. And I'm going to say df equals pd.read CSV. And we will say adult data set. You don't necessarily have to save this as a string. Oops. But I will, because it'll just make this line a little bit cleaner. I could take this string and just put it directly into the function call here. I could just do this and then not have to save it to a URL, to a variable. Okay. So here's the first 5 rows, and I'm also going to use something called the shape attribute. So I'm going to print the shape of the file here. This tells me this file looks like it has 32,560 rows and 15 columns. However, you'll notice that does not match what we saw with UCI. Okay. UCI said we want 14 attributes and 48,842. Okay. Now let me tell you why this is so far off from what we saw before. Now the reason for this is if I click on the data folder, they have two files here. They have adult.names and adult.test. This is intended to be used for machine learning. And so the names file is a training data set. Excuse me, the adult.data is the training data set. And adult.test is what we call a test or a validation data set. So they originally had, back here, they originally had this number of rows, but they've split it up between the two. And because they've also split up data between the two, they have 14 attributes here. And then they have one Y variable, one thing you're supposed to predict, which is this final column over here. So just letting you know, it's okay that we're not seeing exactly the same number of rows and columns for this data set. So don't worry about that too much. However, we do have missing values. And I want to point out something here that if I put in a different number here in the .head command, I'll have that many rows of the data set shown to me. Okay. So as I do df.head here, I can see that. Oh, I could also use the curl command here to look at the raw contents of the file. Good practice to get in. Okay. It's a big file, all these rows. Okay, you try and get back up here to the top of it. Oh, and we flew past it. All right. Oh, it's only showing me the last few lines. All right, but I guess we could take a look at some of this here. You'll notice that this is actually not a comma separated file. All right. What is the delimiter or what is the separator between different values within a row in this file? Right. Might be a little bit of a confusing question. Right. But what separates the different values in a row? Yeah, both a comma and a space. All right. So I say comma space between these two values, comma space between these two values, et cetera, et cetera. And this is okay. For some of our numeric values, that's not going to pose a problem. But for some of our text values, some of these strings, this space is going to be interpreted as being part of the string. All right. And that's going to cause us some problems. So that's going to be something here. We would be able to see that if we had a little bit of experience loading data sets here and actually looked at the raw contents of the file. I'll show you one other thing we need to be worried about. See if I can find an instance of it. Yeah, right here. This question mark. What do you think this question mark represents in the context of this data set? Yeah, good. It's a missing value, a null value, an unknown value, right? Missing information. I think this particularly has to do with the country of origin a person was from. Maybe somebody doesn't know what country they're from, something like that. I'm not sure. Maybe they're not a citizen and they don't want to divulge that they're not a citizen. I'm not sure. But for whatever reason, we have some missing information in this data set. You can see a few more of them over here. All right. We don't want to have missing information be represented with strings, be represented with question marks. We want them to be represented with nans, as we talked about a little bit in the pre-coursework. All right, so we've got these two issues. We've got comma space separators, and we've got question marks being used as a missing value indicator, but that's not what we want to use. We also have the problem here that we had before. I'm going to clear this output, where we don't have column headers yet again. All right, so here, instead of having you type out the column headers, I'm going to paste them for you one more time. Okay, there's the column headers, and we're going to use those here as well. Okay, here's our column headers. And then I want to say the names parameter. I want to set that to be the column headers that I just pasted in above. We've already done this before, so that fixes the column headers. We're good to go. We see the bold things here. They make sense. They seem to correspond with the values in their columns, and we see our bold incremental integer values here for the row index or for the unique row identifiers. So that's good. That's working the way we'd expect it to. All right. The problem here is when I check for null values, I will typically use this command, df.isNull. Now what this does is it looks through my whole data frame, and any place it sees a null value, it will turn that to be true, and any place it sees a normal value, it'll change it to say false, right? So what I can do is I can sum up the number of trues in each column by calling the sum command after this, right? So df.isNull changes everything to trues and falses. .sum will sum up the number of true values per column. So remember, what does a true represent? True in this context represents it was a null value. So the number of trues is the number of null values in a column. And as I run this, it says, hey, there's no null values in this data set. But because we did our homework, we know that that conflicts with what we would expect. We would expect this data set to have missing values. And we also know that conflicts with our understanding here because we looked at the raw file and we saw those question marks, right? Because we did our homework, because we were thorough when we started, we kind of already have an idea about why this is happening, why this code, which we would typically run, is not doing what we would expect it to do. All right. So up here above, I've printed out the first 15 lines of the data set. All right. And you'll notice here on line 15, we've got a pesky question mark. All right. There's a few different ways of dealing with this question mark. But as you're going to notice here, as I show you some of these ways, they're probably not going to work the way you'd expect them to. Okay. So I'm going to reread in this data set. I'm going to keep on looking at the first 15 lines. And there's another parameter we could use. It's called NA values. All right. This means wherever you see pandas, wherever you see this value in the data set as you're reading it in, replace it with a nan, replace it with a null value, and then code like this should work. Right? So I'm going to do this. I'm going to try and replace those values with null values and sum them up. And you'll notice we got zeros everywhere, and we still have a question mark. Okay. So basically what you're seeing here is this didn't work. This didn't do what I expected it to. Does anybody have an idea why looking for NA values of question marks didn't accomplish what we wanted it to? But there's a question mark right there. I could see it. Okay. Good. You guys are on top of it. Yeah, we don't have the space there, right? So let me actually even show you. This is in the native country column. I want to look at values from the native country column. And I want to look at row 14. Okay. This cell does not hold a question mark. It's space question mark, right? We can't see that in this output. It doesn't show us those leading spaces. So sometimes we might need to go and print out the specific value of a cell to have a better idea, all right? But now if I say NA values is space question mark, all right, then it does get caught and does get replaced with a nan, whoops, which is exactly what we want to see. And now df.isNull.sum tells us the number of nan values, the number of null values in each column. So we have some people who don't have a working class, maybe they're out of work. Roughly the same number of people who don't have an occupation, and some individuals where we're not sure about their native country. Yeah, so Aliyah asks, is question mark a string data type? Yes, it is. So anything that is not an integer or a float will be read in as pandas as a string. So we actually don't have any floats in this data set. We only have whole numbers. A number is a float if it has a decimal portion attached to it. So like 13.5, that would be a float. But 13, just the whole number, is an integer. All right. Yes, anything that is not numeric will be read in as a string, basically. All right, so we now have this data set, I would say, read incorrectly, right? And yet again, how did I know to use this NA values parameter here? Well, documentation, right? Go to the documentation, read about it. I don't have the time for the things I want to demonstrate here to go to the documentation for every little thing I want to show you here today. So I kind of just had to pull this out of my hat. But you may need to do some more documentation digging on your assignment. Right? Great thing to get good at and to build the skill up. Okay, so I've read in this data set correctly now. What are some things I could do to learn more about this data set? All right, I'm going to show you some different default exploratory data analysis functions we could use here. So the first one I want to show you is the .describe function. df.describe shows me what I call summary statistics. Well, I don't call it that. The field of statistics calls it that. But these are basic pieces of information that kind of summarize what our different columns represent. So you notice we have the mean, the median here, the 50th percentile, the min and max values, standard deviation, right? Lots of just basic statistics about different columns in our data set, all right? But however, I don't see all of the columns here. I only see a few of the columns. Any idea why I'm only seeing these columns? As a hint here, I'll just show you the first few rows again. Why am I only seeing the age, final weight, education, num, capital gain, capital loss, hours per week? Yeah, good. These are the only columns that hold numeric values. I can't calculate a mean of strings. I can't calculate a median of strings. Yeah, so it's only showing me the numeric columns by default. However, I can coerce df.describe to give me non-numeric columns and give me a summary of those. If I say, let's see, is it exclude? Again, I would know how to pass this parameter by going to the documentation. Say if I exclude the numbers, well, now it gives me summaries of all of the non-numeric columns. We sometimes call these categorical columns, right? And it says, okay, there's 8 different unique values that can be had for private class, 16 different strings of educations, 7 different types of marriages or marital statuses, 14 different occupations, 6 different kinds of relationships, 5 different races, 2 different sexes, 41 different native countries, and 2 different levels of income that have been recorded here. Okay. So .describe by default gives me only numeric values. I can pass this parameter to get non-numeric summaries, and I could also say include all if I wanted both. Okay, but you'll notice anywhere where it doesn't make sense to have both of these things, right? It doesn't make sense to calculate some of these numeric things on a categorical column. I get nans. Basically, hey, it doesn't make sense for me to report values here in these sections, so we'll fill them with nans. You'll also notice that some of the counts are different, right? So we've got 32,561 rows here, but only 30,725. That's because we had some missing values here in work class. All right, so those missing values don't get counted towards the total count. So if you see different counts here, that'll give you an idea about we probably have some missing values here in those columns. So we have some missing values here in occupation as well and in native country, like we saw above when we did .isNull .sum. All right. So that's the describe call. This is a very useful thing for just learning some basic things about our columns and what they represent. But you'll notice that some of those columns were used in the .describe column because they held numeric values, and some because they held categorical or string values. So if I actually call df.dtypes, what is wrong? Oh, wow, I really spelled that wrong. df.dtypes, it'll tell me the kind of values that are held in all of those columns, right? So in the age column, final weight, education, those all held integer values. And everywhere where you see object, that means there was string values in those columns, more or less. All right. So this shows me why I got different outputs for the two different describe calls, because the items or the information in those columns held was represented in different ways, was represented using different kind of underlying data types, integer values versus strings. All right. Let me see. I've got some notes here about a few more things I might want to show you. Okay. Shape head d types dot describe for both numeric and non-numeric. We've done is null sum. Let's try drop NA crosstab value counts. Okay. So I'm going to show you value counts next. A very important function. Value counts, what it does is it takes on a specific column. For example, let's say the marital status. And it's going to tally up all the different values in that column. Okay. So here's all the different marital statuses. All the different string values in that column are here on the left. And the number of times each of those was mentioned is here on the right. So most people, looks like we're married civilly to a spouse, never married, divorced, separated, widowed, married with a spouse absent, and then married AF. These people were really married. No, I'm just kidding. That's armed forces, not married AF. Anyway, so that's what value counts does. We can call this on any column here. What's another column I want to call this on? This will typically work better with object columns, things that hold strings. If I call this on a numeric column, like the age here, it's like, oh, there's so many different ages. It has a hard time even showing me all of them, right? So let's do this on education. Okay. Then here's all the different tabulations of how many people were high school grads, how many people had some college, 10th grade, 11th grade, etc. All right. So value counts, very useful for tabulating the different categorical values in one single column. All right. Now that is in contrast to something called a crosstab. So if I say pd.crosstab here, I'm going to pass in two categorical columns. So I'm going to pass in marital status. I'm also going to pass in education. All right. Now what pd.crosstab is going to do is it's kind of do both of these two value counts at the same time. It's going to tabulate both of them, right? So in these cells, this is the number of people who had obtained 10 years of education and were divorced. Number of people who obtained 11 years of education and were divorced. Number of people who obtained 12 years of education and were divorced, right? So I see kind of the interactions between these two different categorical variables, all right? And it all gets kind of summarized and displayed to me in one single column. So I see that most people were high school graduates or had some college. Most people were married civilly. We've got a lot more columns in those, and a bunch of people were also never married, right? So if I added up all the numbers in this table, what do you think they would add up to? If I added up all the numbers in this table, what do you think they would add up to? I'll give you a hint. Okay. Brittany says the total. David says the shape of the table. Yeah, but what does this shape represent? This shape is the number of rows in the data set and the number of columns in the data set, right? So if we add all this up, it should add up to be the same as the number of rows. Why? Because each row is one specific observation. When we have one person who's divorced and he's in 10th grade, we have another person who's married to their spouse and has a bachelor's degree. So we have 2,768 different rows of people who are married civilly and had bachelor's degrees. And we're just adding up, we're just tabulating or quantifying how many different rows in the data set had uh, had both of these categorical values, right? We're a bachelor's degree and married civilly, right? So I hope you can see a little bit that our crosstab is kind of like value counts, where we're tabulating things up for different categorical variables, but we're then also looking at the kind of the distributions across both of those categorical variables, all right? Now, crosstabs, we're gonna do a lot more with them in the future. I've introduced them super briefly here, but one of the reasons why I introduced them is because they allow us to do some pretty cool, make some cool graphs, which I'm gonna show you here in a minute. I do wanna show you two more functions here. The df.drop function will help me drop either specific rows or specific columns of a data set. So say I didn't want the age column anymore, right? If I do this, df.age, it's gonna say, eh. Oh wait, it actually didn't get mad at me. It just didn't do what I wanted, right? It still has the age column. I think if I, well, basically df.drop, what it does is it can drop either rows or columns, right? But by default, it tries to drop rows from my data frame. If I want to specifically drop columns, I need to say axis equals 1. And this is something that's very common with pandas. If we want to do an operation on the columns, we'll say axis equals 1. If we want to do an operation on the rows, we'll say axis equals 0. All right. So axis equals 0 will do the same thing as what I did before. But if I say axis equals 1, it should actually then drop the age column. But it's not. That's very weird. Let's just take a look at our data frame here. Okay, looks normal. Oh, you know what I think? I don't want to select the whole column here. I just want to pass the column header. Just the column header itself. I think that will then do what I expected it to do. All right, there you go. Now you notice we don't have the age column anymore. If I say axis equals 0, it's going to complain. Say, hey, I couldn't find any age header for the rows because the rows are identified. Wait for it. Not using column headers, they're identified using these integer values, right? So if I forget to say axis equals 1, it's going to say, hey, I'm confused. I don't see anything called age. I don't see any row that's called age. But if I say axis equals 1, it'll then know to look for column headers called age, and then it will be able to drop it. Now, what I've done here will not actually change the data set itself. Notice if I do df.head, the age column is still in here. It's still in here, right? So why did this not change it? Well, because this is returning back to me the modified version of the data frame. If I want to update the variable, the df variable that's holding this data frame, I need to save back over that variable. I could also pass a parameter called inPlace equals true, and that'll do the same thing as saving back over this variable. But I don't like using the inPlace equals true parameter. It's going to be deprecated in the future. It will be removed from pandas at some point. So I encourage you to just save back over the original variable if you want to make a change. So now if I call .drop and save back over the original variable, and then I do df.head, now I've actually modified this variable, and the age column is now kind of permanently gone. So you have to be careful with some of these things because that will cause some issues. All right. One other function I want to show you here is the drop NA function. What this will do is it will drop null values from a data set here. I'm calling it on the whole data set, or I could also drop null values from a specific column like occupation, right? And just drop rows that have null values. But I'm going to do this on the whole data set just for demonstration purposes here. And then I'm going to show you the shape of the data set after I've dropped those rows. And I'm going to print the head. So df.head. Okay. So notice I now have a whole lot less rows in the data set. I started off with 32,561. And now after I dropped all those columns that had nans, I've lost 2,500 rows, right? Because it dropped any rows in the data set. If there was a nan value, if there was a null or a missing value, anywhere in that row, we dropped the entire row, all right? So if you have a data set that has a lot of missing data, this could be a costly thing to do. However, but when we get to kind of machine learning models and some of those things, machine learning models don't do very well if we have missing data. And so being able to handle this missing data, either fill it in with something or just drop it from the data frame is a good basic skill to have. All right, so if I do df.isNull.sum, remember that will quantify or tabulate the number of null values that I have. It's going to report back to me zeros now. And this is correct, right? Because I basically dropped any rows that had a question mark. We actually then replaced those question marks with nan values, but any of those rows that had nan values got dropped. All right. So these are just some very, very basic kind of introductory functions that we can use with pandas to do some basic things about our data set, explore our data set, maybe even clean it up slightly. But you'll notice basically everything that I did here, I called on df. df.isNull.sum, df.dropNA, df.head, df.drop, df.shape. The only differences here, I did not do that with crosstab. This was from pandas, pd.crosstab. And I called value counts on specific columns. So I also included the column header here. It wasn't df.valueCounts, it was df.education.valueCounts. And df.dtypes, df.describe, right? So calling all these functions in very similar ways, except for crosstab. Crosstab's a little bit different. All right. And these are some basic things we can do with the pandas library to learn things about our data sets. All right. The last thing I'm going to show you, and I'm going to show you this pretty quickly, is we can make some basic graphs with pandas. If we want to explore this data, we want to plot it, see how it looks. This is the last thing that I'll show you here, and then we'll answer final Slido questions. Then I'll let you go to lunch. We've gone a little bit over time here, which does happen sometimes. If we go over the hour mark, just push your lunch back. Always take a full hour for lunch. All right. So even sometimes if I get a little bit long-winded here and don't have perfect time management, you'll hopefully still be okay. All right, so a line plot, say I want to make a line plot on a specific column. All right, so I'll access that column here. I want the education num column, and I could call something like a value counts. Actually, I don't love this example. That's okay. All right, so I'm tabulating up all the different number of years of education people obtained, but notice they're all kind of out of order. If I just call .plot on them right now, this plot looks pretty wonky. All right, it doesn't look like a very useful plot. That's because all of my years of education are ordered based on the number of individuals who had obtained that number of years of education, not based on the kind of this left-hand column. So the sorting here has happened based on the tabulation and not based on the number that's representing the number of years of education a person obtained. So I could then say, I could sort this based on its index. So this left-hand column is called the index. Okay, so now it's been sorted by the left-hand column. And then if I call .plot on it, now I see a distribution of the number of years of schooling obtained. So we see that most people here are obtaining, 9, 10, 11 years of schooling, and also some people who got maybe a little bit of college or maybe a bachelor's degree, right? But the cool thing about pandas here is I have stuff in my data frame that I've read in from a CSV, and I can chain lots of functions together if necessary in order to do some things here. But I can make a line plot by calling just .plot on the end. So this .plot function is what we're going to use heavily. Now, if I hadn't done this value counts or anything, it would look pretty messy. Okay, so doing this value counts beforehand kind of cleaned up some of my data before I plotted it. And you also notice I get this funky output here at the top. If I want to get that output to go away, I can put a semicolon at the end of this line. Now, semicolons are not really a thing in Python. This is not a Python-specific piece of syntax. This is a piece of syntax that is specific to the plotting library that's being used by pandas to do this, right? So this is This is not a requirement to put semicolons in Python, but it does clean up the output here of this code cell. All right. So I'm actually going to put in another code cell here just to remind you about why we sorted the index here. So we wanted these to be in order of year, and then call just dot plot, add dot plot to the end of it to make a graph. All right. So that is a line plot. Just call dot plot. If we want to make a histogram, something very similar. But instead of calling dot plot, I call it dot hist. Hist for histogram, right? And again, I can add that semicolon to squelch that funny string output at the top. So here's a histogram, 10 different bins. You'll notice it kind of matches our line plot. Actually, the points where this line plot goes are exactly the same points that would be the top of our bins here. However, this is only 10 bins, and I have, 16 different years of schooling. So I could say bins equals 16, and I'll get now a different line for each year of schooling. Now it really does match our line plot almost basically exactly, which is pretty cool. Making a histogram with pandas is just that easy. This is one of the reasons why we're using pandas and starting off with it at the beginning of the course. We can load data sets, we can clean data sets, we can learn about data sets, we can easily plot and visualize our data sets. It's going to be our bread and butter for a lot of the course. So we're getting associated with it here on day one. A scatter plot is a little bit different. Say df.plot.scatter. And then I'll pass in the column headers of the two columns I want to plot against each other. All right, so I want to show a comparison between age and hours per week worked. Oh, I dropped the age column, so that's not going to work. Let's look at education num. Okay. We're seeing different levels of education on the x-axis, hours per week worked on the y-axis, right? Maybe this isn't like a great choice of two things to build a scatter plot from. Maybe we should use whatever this is, final weight. We'll plot hours per week against this value. Okay. I'm not really sure what this final weight value represents. We could look at the data dictionary here, but a somewhat more interesting scatter plot. We see this distribution that kind of gets wider here, and people working around 40 hours per week, but smaller when people are working extreme numbers of hours, either not working at all or working 100 hours per week. All right. So that's scatter plots with pandas. df.plot.scatter, pass in your two column headers. Okay. A density plot is very similar to a histogram. It's kind of like a smoothed out histogram. So if I I dropped the age column, we'll do education num again. It's got to be a string. I probably shouldn't have dropped a column that I wanted to use in plotting some of my demonstrations, but that's okay. So dot plot dot density instead of dot plot dot hist. Okay. So what this is showing us is a smoothed out histogram. Okay. A smoothed out version of a histogram. Now, we'll be using these density plots a little bit later on. What's happening is area under the curve with these density plots represents probability, whereas the bins here just show the size of specific categories. I could look at the area under the curve between 10 and 15 to know the probability of an individual in the census having between 10 and 15 years of education, right? So density plots are more useful when we're thinking about probability. Histograms are more useful for just visualizing the distribution of two things, sorry, of a variable. All right. Last but not least, I'm going to show you an example here with a crosstab. Okay. So we're going to make a crosstab here of a person's sex and number of years of education obtained. Okay. Pretty simple crosstab. Number of years of education up here as the column index, and then sex of the person responding to the census here as the row index. Now, one of the coolest things about crosstabs is I can call .plot on them and make some cool plots. Sometimes these plots end up looking up more like modern art than useful plots. That's definitely the case here. All right. But with a little bit of tweak, with a little bit of look at documentation and understanding of different different parameters we can pass here, we could actually do some things that are maybe a little bit interesting. Okay. So I'm going to swap the order of these two. And it starts looking a little bit better, right? Right. So it's going to try and plot the column index on the x-axis and the row index on the y-axis. The counts on the y-axis, which is why it didn't look very good before. All right. But this is kind of pretty cool. I can see a comparison between males and females and the number of years of education they've obtained. Now, if I just look at the sexes of people here, you'll notice this data set has about twice as many males as females who were respondents to the census, right? So the fact that this orange is so much taller does not necessarily mean that, that males are obtaining education at a greater rate than women. It just means we had a lot more male respondents to the census here. But there's a lot of cool things we can do with plotting crosstabs. I'll let you experiment with some of these things later this afternoon. I could say, well, make this a bar plot. Same data as before, but with these paired bar plots, which is kind of cool. I could, I'm not going to show you everything that's possible here with a crosstab, just a few of the basics. I could say, I want a horizontal bar plot. So bar H for horizontal bar. Now it's horizontal, right? And it's just this easy with pandas to make some cool plots from a basic data set that we've loaded in. So I'm going to say kind equals bar, stacked equals true. Now I've got a stacked bar chart. We've combined the heights of males and females. So the heights here on the stacked bar chart should match the heights of my histogram, right? Should look very similar to my histogram, but I can see the breakdown throughout the two different categories. All right, so today, just an introduction to pandas. Let's get into it this afternoon. Let's play with it, practice doing some of these things. Basically, your assignment this afternoon is, and you'll see this as you open up that file, pick 2 data sets from UCI, and you're going to practice doing a lot of the things, same things we did during lecture, which is why these lecture notes and the lecture video are going to be so helpful to you. You're going to load one of those data sets from its URL. You're going to load the other of the 2 data sets from a downloaded version of the file. Practice both of those methods, and then you're going to be asked to do some exploratory data analysis functions and to make some simple plots, all right, for both of those. Now, if you're doing a crosstab, crosstabs are going to work better if you have categorical variables. All right, so if you have one data set or the other that has categorical variables, one does or the other doesn't, try and use whichever one has categorical variables for your crosstab. If neither of them have categorical variables, because by the way, you're going to get to choose what data sets you use. What I want you to do for choosing the data sets is, now I'm getting UCI issues here, okay? Here's UCI, it's not letting me in. I'm gonna say advanced, proceed, unsafe, but I'm like, I trust UCI, right? I want you to pick your data sets from this right-hand side here. These are the top, I think 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, top 12 most popular data sets on UCI. I want you to pick the 2 data sets you use on your assignment from this list, all right? So yeah, if you can't get into the URL, if you had the issue like I just did, do the same thing I did where I said, you know, advanced, proceed. I still want you to use this. We're gonna have to do a little bit of tweaking to help the URLs work, to not have the SSH issue. So I'll look into that during lunch and let you know what you need to do in order to be able to read data sets in directly from UCI. And there's already been some great comments above from Jacob about what we can do. So I'll look into that and give you more consistent response. All right. Take a look at Slido. Are all the lessons this fast? No. This has been pretty fast, and that's partially just because I've trying to cram so much in here on the first day with GitHub stuff and now assignment stuff. No, the lessons will not always be this fast. I think you will find them to be a little bit fast, but I'll try and be more evenly paced in the future. Okay. So yet again, use the video heavily, the recording if you need to, use the lecture notes heavily if you need to. And some of those other questions you guys asked in Slido earlier, I'll answer those asynchronously here, just typing in Slack here in a minute. Are there any final questions before I let you go for lunch? Okay, I see some people typing. This afternoon when you come back from lunch, what do I want you to do? I want you to dive into that other notebook that's in the GitHub module for today. All right. And that's going to have instructions about your assignment, similar to what I just explained verbally. And then by the end of the day, you know, you've done some work on your assignment, save those changes back to GitHub and then open a pull request. All right. That way the team leads can find your work and start grading it, giving you feedback on it. All right. And then towards the end of the day, by the way, throughout the afternoon, if you have questions about things, feel free to ask questions in Stack Overflow, ask questions in DS15. Let's collaborate, let's discuss. You don't need to go and work you know, in total isolation throughout the day. Remember the 20-minute rule. If you're stuck for longer than 20 minutes, reach out for help. We'll kind of work together on some of these things. It's not as strict as maybe a traditional school where it's like, oh, you can't talk to anyone about your assignment, right? Feel free to work together. By the way, don't just wholesale share code with somebody else. Don't just do their assignment for them, for another student, right? Try and be sensible about these things, but you can collaborate. You can work together. You can ask questions on these things. Jaleesa asks, are we coming back to Zoom? So yes, we will have a wrap-up Zoom call at 4:15 Pacific in your team lead group. So it'll be a smaller Zoom calls, similar to what we did this morning. And you'll give a status update in those Zoom calls about how your day went, talk about if there's anything that was blocking you, if there's anything you're particularly confused on, you guys can work on it together. Your team leads can help address some of those questions. All right, so after lunch, we're gonna mainly work kind of asynchronously, work on your own stuff, discuss through Slack, discuss through Stack Overflow, and then get back together on Zoom at 4:15 for our afternoon kind of report. We call it a stand-up. All right, afternoon stand-up meeting. Okay, so enjoy lunch. Remember, push your lunch back. Take a full hour for lunch, even if I go over time here with lecture. We can communicate a lot through Slack. I'll be available for anything you need throughout the entire afternoon. So thanks, everybody. Thanks for your participation. I hope you're excited to get started, and I'll see you after lunch. Thanks, everybody.